Hello, and welcome to episode 160. Thank you very much for joining eCHO this week. Today I'm going to be kind of covering two things. The first bit is going to be a kind of quick overview of the sessions that I'm kind of excited about for next week at KubeCon. And then the second half is going to be a bit of content that I covered at an earlier event, which is going to be all around eBPF programs inside of Kubernetes. So effectively, if you're wanting to run your eBPF programs on a bare metal server, then you can kind of do that. ETH0 is ETH0, libraries where you expect them to be, all of those sorts of things. However, if you are wanting to attach eBPF programs inside a Kubernetes cluster, where should you be attaching your probes? Where should you be attaching your eBPF programs? Where do the libraries live? There's a myriad of gotchas and things like that. So we're going to have a bit of content. We're going to step through that. And if it all goes okay, there's a bit of a demo as well. So let's kind of kick things off. I think, as most people know, next week is going to be KubeCon North America. And we're super excited this year that we have let me get the naming right, Cilium and eBPF Day. So this year it's going to be a combination of talks around Cilium, CNI, service mesh, encryption, cluster mesh, etc. And then also some talks around eBPF as well. So it's going to be kind of combination of the two. So a huge amount of talks for people who are interested in such things. And let me kind of quickly bring in. So all of the schedules are now live. You can see all of them. Oh, this is the wrong one. 1 second, bear with me. Okay. So yeah, this is the right. Sorry, I'd accidentally got the schedule for the previous KubeCon in Europe. So in terms of talks that I'm excited about, first talk that I'm quite excited about is it's a funny one, this one, but the main point really is there's been a lot of kind of conversation around the maturity of eBPF, and last year, or earlier this year, sorry, John Fasterbender and Liz Rice put together a talk all around eBPF being Turing complete. A lot of people say if it's not Turing complete, then it's not a real language. Well, in this kind of keynote, Liz will be demonstrating that, and Liz will be using effectively the game of life implemented in eBPF to demonstrate the Turing completeness of eBPF. Additionally, some other good talks that kind of piqued my interest, things around kind of writing into memory with eBPF. So being able to look at things like the BPF arena, which was introduced in a relatively modern kernel. A good talk from Dave Tucker around kind of some of the stuff that I'll be covering a little bit, but mainly, kind of how they migrated various probes and whatnot into eBPF and the various libraries that they needed to look at to do that. So things like the Cilium eBPF library, BPF to go, and effectively how they kind of use that to modernize the probes that Kepler uses. And Kepler is the acronym's quite it's Kubernetes power monitoring, effectively. So quite cleverly, what it does is it can understand what's actually happening inside the CPU, and then build from that information based on hardware usage to determine how much power a process is actually using. So things like the Kubernetes API server is burning X amount of watts per hour based on how much time it spends in the CPU, based upon how much hardware is behaving and things like that. So those are kind of the three main ones that kind of caught my eye, but there's, I think, at least 13 or 14 other sessions throughout the day that will be taking place on the Tuesday at Cilium eBPF Day. Quick little shout out to Ganitak. Hello there. If you have any questions, please let me know. And then the rest of the event. So Cilium eBPF Day is part of the co-located events, which start on the Tuesday. The Wednesday, Thursday, and Friday are then dedicated to the rest of KubeCon. So it's easy to find the additional sessions. So there's at least another 16 sessions kind of devoted to, or mentioning eBPF that will be taking place on the Tuesday, Wednesday, and Thursday at KubeCon. So a couple of interesting ones here that kind of caught my eye were this one. So eBPF, using it to intersect and understand encrypted network traffic, which again kind of leads in nicely to something that I'm going to cover a little bit later down the line. Depend on their implementation, it'd be very good to see kind of what it is that they're doing in order to detect these sorts of anomalies. And then additionally, a new feature that's been kind of added to Cilium recently, but that is using eBPF to do multicast traffic in networks. So being able to send traffic to multiple destinations through eBPF. So those are kind of the main things that kind of caught my eye. Those are the main talks that are going to take place both at the Cilium and eBPF Day, along with the rest of the KubeCon sessions that are good there. Two other things as well. So people who are wanting to get into eBPF for the first time or wanting to contribute to existing eBPF programs, there are the concepts of contrib fests. So if I quickly pop back to the schedule here, we can see here on the Thursday afternoon, there is 2 contrib fests. So what you can do is you can join these contests. Developers of Inspector Gadget and the developers of Tetragon will be there, the maintainers, etc. So it's an opportunity for you to meet these people, sit down with them, get a greater understanding of the project, a greater understanding of how eBPF is actually powering it. And then also, if you're wanting to go down the road of becoming a contributor, this is a great way in order to kind of find the best way, find out what help is needed for the project and how you can contribute, how you can make meaningful contributions. So I say KubeCon is next week. There's a lot of talks to be part of. And then KubeCon is over, but it isn't, because KubeCon is never over. Once KubeCon finishes, there is a week for you to think about contributing your CF to the next KubeCon, which will be taking place in London in April 2025. So if you do have ideas for eBPF or Cilium-related talks and you need any help with that, any suggestions, please join, or if you're already part of the Cilium Slack, head to the general channel, ask questions in there. We're more than happy to help you kind of get your talk put together, help you get it into a state where it's likely to be accepted through the CFP process and things like that. So as I say, KubeCon never ends. KubeCon is next week, and then the next one will follow shortly afterwards. So that's my kind of overview for upcoming KubeCon. I say there's a lot of talks around eBPF, there's a lot of talks around Cilium, and a lot of talks around everything in the Kubernetes ecosystem. So with that, we will move on to the talk around Kubernetes and eBPF. So we bring in my laptop. So the beginning of this talk, and it's on YouTube should you want to go watch it in its entirety. The first half of it really is kind of for people who've never used eBPF before. And assumptions are always a terrible thing, but hope, I suppose, that most people understand kind of what eBPF is who are joining the eBPF Echo live stream. And as I mentioned at the beginning, on a bare metal server, you understand the lay of the land, you have your eBPF program, and you typically will attach it to something, a device, etc., where you expect that to be. That's not quite the case in sort of Kubernetes, so we'll kind of step through some of this. Sorry. So eBPF programs in a Kubernetes cluster. eBPF programs, you don't run them by yourselves. They're not ELF binaries, etc. We need to load them from the file system or from somewhere. So they need to be accessible in order to load them. And there are a number of different ways of loading your eBPF program. So there are just the general syscalls. There's the BPF tool, CLI. And then there's additional tooling, the Cilium eBPF project, for example, IRA for Rust programs, libBPF for C programs and things like that. The syscall, typically you will open the file that you care about, map it to memory, and then use the syscall in order to load that program, and then finally attach it. With Cilium and eBPF, typically we use the Go generate method inside our Go program, and that will compile our C program. It will use BPF to go to turn our C program into an object that lives within our Go code. And then finally, it will create functions for us to load that and attach that. So effectively, we'll build our code, our eBPF code, and bundle it with our Go binary, and our Go binary will load it at runtime. Just a quick hello. So a quick shout out to Joseph. Hello. If you have any questions, anything that you need me to explain, please do let me know. So that's how we typically load them. There's, as I say, syscalls, CLI tools, wrappers that will take our code and bundle it with our other code in order to load it at runtime. Once the code has been loaded by the kernel, we then need to attach it somewhere. So there's a myriad of different places we can attach things, a lot more than I'm kind of covering here. But from my perspective, at least, the main places you tend to see your eBPF programs being attached is the networking. So XDP, if you want to do it super low level, or TC, so the traffic control, if you want to attach it a little bit closer to where the kernel is doing things. And then various points in the kernel, so we can attach to kfuncs and user probes as well. So, you know, kind of attaching to system libraries and things like that. And so this is kind of where things get a bit more difficult in Kubernetes, because things aren't what you expect them to be. So eBPF in Kubernetes, I suppose the slide is a little bit pointless, but when running your eBPF programs in a containerized environment, you literally have two options. You either attach from outside the Kubernetes cluster, or somehow you have your eBPF program inside your Kubernetes cluster. And all of this really means that the architecture in your head as you're architecting all of this is going to require a bit of thought process in terms of how you're going to architect your program and where things are going to attach. So outside the cluster, you're going to see effectively the results of everything that kind of Kubernetes has been doing. So network traffic typically will have potentially already been mutated. There's a fantastic diagram out there which effectively shows, you know, if you attach TC egress, for instance, everything has already gone through the kernel, it's already gone through IP tables. You're effectively seeing the traffic as it is about to hit the network adapter and leave the machine itself. So if you're wanting to mutate traffic at the egress point, you know, kubeproxy will have done a million different things, and the traffic that you see, you're going to find it hard to understand, and it's going to be hard to correlate, you know, kind of what's happening based upon what it is that you're trying to do. And additionally, and this is kind of one of the more interesting project problems as well, is uprobes. So if you're wanting to attach to a library that is doing something and you want to, you know, see what's happening inside that library and interact with it, etc., we need to physically attach to the correct library, the library that the program that we care about is using. So, and the example I'm going to show in a little bit is going to show this, but effectively, imagine we have curl. We don't need to imagine, hopefully I'll demo it a bit, but imagine you have curl and we are curling out to a website over HTTPS, and we want to use libSSL, libSSL's read and write functions to actually see the raw data as it's coming in and out. If I'm outside the cluster and I connect my uprobes to libSSL, the library, I won't see anything. I won't see anything from the read and write functions that I'm expecting to see, because that's not the library that my curl program in my pod is actually using. So hence the bottom line, which is, this is the conundrum of finding the correct library to attach to. How do we find it? A couple more shout outs. Hello, Tony. Hope you're well. And hello, Marco. Cool. So let's carry on stepping through. So inside the cluster, again, more thought press needed. I do apologize. I've got a bit of a cold at the moment, so I'm sniffling a little bit. Inside the cluster, we need to find a way of getting our eBPF code into the pod. We need to bundle our binary, our eBPF program, one way or another. If we're mutating the traffic inside the pod on its internal adapters and things like that, then if we mutate it too much, the packet will change. It will come out to the CNI, for instance, or kubeproxy. And kubeproxy won't know to watch for it because it'll be different traffic. So there's a good chance we may break Kubernetes networking. And if we do that sort of thing, the only way for us to ensure things are going to have expected behavior is potentially to re-implement some of that behavior for things to actually behave how we expect them to behave. So networking. This is the diagram that I was talking about. It's far too big probably for you to see, but these slides will be available on SlideShare. But the main point really is where we want to attach to. I don't think you can really see my mouse pointer or anything like that. No. Oh, you can. There we go. So where my mouse pointer is the beginning of the journey of traffic moving into the cluster. I apologize, it is small, but that is the XDP hook. That is before anything actually happens. Later down the line, traffic control, so we can attach here. And then after that is IP tables or net filter, etc. So NF tables, IP tables, whatever. All of this is in kernel processing and mutating of the packet. So we need to be aware of where we actually want to attach our eBPF probe to, because once it hits the net filter, who knows what's actually happening. And that's ingress. If we look at the top here, that's our local process. And if our local process is the one initiating a connection, so it's doing egress. So for instance, if our pod is curling out, all of the net filter stuff is going to happen before it hits our egress Q disk, where our TC program would actually live. So it becomes very hard for us to understand the traffic because we can't really capture it egress-wise with kubeproxy in the way. And this is why Cilium with kubeproxy replacement and its egress, it understands all of that, because there's no myriad of IP tables doing, kind of Kubernetes egress and things like that. It can sit in that and expect traffic to look as it looks and understands it a bit better. Let's break it down though, as I mentioned. So we can attach with XDP. We can attach here at the traffic control ingress. Then there's the IP tables madness, and then traffic will eventually get to your process. And it's the same in the opposite direction. If you attach at the TC egress, you're going to get the results of everything that's happened in kernel with those IP tables rules. So, as I say, when you're writing your programs in Kubernetes, you're going to need to be aware of what you receive has already been processed in the kernel via those IP tables rules. Right, so... Oh, yeah, so quickly step things. I believe people have already seen this before anyway, but this is effectively what it looks like when you receive packets. So typically a bit of C code here. So we get our socket buffer, which I briefly showed you earlier. We point to the beginning, we point to the end. So these are our 2 pointers, so we know exactly how long the data that we've received actually is. We'll create an Ethernet pointer of type Ethernet header. So now we actually can see inside that structure at the beginning of the data. We can check that the protocol is IP. We can then point to the data after the Ethernet header. So the size of the Ethernet header, create a pointer to after that that's of type IP header. And now we can access the members of the IP header structure. So we can look at the protocol in there. If it's not TCP, then carry this packet to do what it's doing. And then finally, TCP header. So we create a pointer of Ethernet header plus IP header. Now we're pointing to the beginning of the TCP header section. We can start to look at the data that's inside all of that. So looking at things like source and destination ports. And then finally, we can effectively work out where the data starts by getting the size of the TCP header, because there can be variable lengths. Not always, but sometimes it can be. And then taking the header length plus the IP header length plus the Ethernet header length. That gives our offset for where the data starts. And we can then work out how long the rest of the data actually is. So how that works, it looks like this. We know the Ethernet header is this long. We know the IP header is this long. We know the TCP header is this bit. And then everything after that is actually application. So if you want an eBPF program that's going to understand and parse application data, your pointer then would begin at packet offset, and you have packet length to know how much packet data actually remains that's layer 7 information and things like that. These are things you need to know, because the verifier will get very angry with you if you try and do anything after the packet length and things like that. So application considerations. We talked about the networking. We've talked about the architecture of Kubernetes and kubeproxy and NetFilter. Application considerations. If we wanted to hook into if we wanted to hook into a program and look at its behavior by doing some observability, or mutate its existing behavior, we may want to kill the process because it's doing something we don't want it to do, or block it from doing something. Typically, we're going to hook into either kprobes, which will allow us to hook into kernel functions, or uprobes, which will allow us to attach to userland functions. And as I mentioned earlier, we have a conundrum with Kubernetes because we need to find the library that we want to attach our hooks into. So there are a couple of options available to us. Some of them are quite gross. Some of them are less gross. None of them, I would say, are particularly nice, but you can still make it work. So the first option really is outside the cluster, where a pod is actually running, where the container inside that pod is actually running. What actually happens before the container runs is its file system is downloaded, so the container image. It is then decompressed onto the file system. So you'll have like var, lib, Docker images, etc. Inside that folder is a bunch of YAML, which describes the structure of it, and you'll need to understand all of that. So in order to work out where things are, we'll need to find the pod. We'll need to find the container that we care about within that pod. We'll then need to find the file system UUID, so where it points to on the disk itself. And then within there, we will need to understand, because some of these images are overlays and blah, 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 blah. We'll need to work out within that nested folder where the library actually lives. And each runtime may do it slightly different. There's a myriad of things that you would need to be aware, and it's not a particularly good solution for being able to find the libraries that you actually care about. A sidecar. So what we could do is we could put our eBPF program into a container, and we can attach it to as a sidecar to the process that we want to care about. So the first time I tried this, I was like, this is going to work. This is brilliant. What I completely forgot to think about is that a sidecar is the same network namespace. So the sidecar shares the same network. However, it doesn't share the process space, and more importantly, it doesn't share the file system. So what that means is that my sidecar can see network traffic going through ETH0 in the pod, but I can't see any libraries. I can't attach uprobes to anything in that container that I'm a sidecar to. There is a way around this. So in order to get around this, there is a change to the spec of the pod that we want to connect to. So what we can do is we can do share process namespace is true. And this has the effect of, if I'm in my sidecar and I look at, if I do a PS, I can now see all of the process IDs from the other pod that I'm the sidecar to. So that's good, but that also has a side effect. Now, if I go to the proc file system and find the PID of the process in the container that I care about, I now go to the root file system and find that root file system. So what I can do with my eBPF program is I can start it up, I can traverse the proc file system, find the PID that I care about, I can cheroot into it at runtime, and as far as my eBPF program and userland side of things cares about, I'm now inside that container. I can see its process, I can see its root file system, I can find all of the libraries that it's caring about, I can attach my uprobes to them, and I can do whatever it is that I want to do with them. So yeah, I'm going to try and do a quick demo. I tried to do this demo at KCD UK, but unfortunately for a myriad of reasons, it didn't actually work. So fingers crossed it works this time. Let's see if I can find it. So, right. So just so you understand here, I've got two terminal windows. The top window is in a Debian container, just because I needed to use curl. If I use BusyBox, it doesn't use libSSL and some other things that you don't really need to worry about too much. But effectively, we can show that if I do. Bear with me. There we go. Oh, LDD, not LLD. So if we look at the library that we care about, so curl, we're going to use curl in the top one to go and interact with a web server. We can see here that the libSSL library that it cares about is libSSL, etc. And if we run the same command in the container underneath, we can see that that's a different library altogether. So curl in the container that so as I said, these are two containers, one that has my eBPF program in, which is the bottom one, and the top one has my my target container that I care about. So what we'll quickly do is, if I do a PS minus here, so we can see here, the other container is basically just doing a sleep, so it's just keeping itself alive. And what we'll do, just to show you, or just to demo, is if I go to proc, so I'm now in the proc file system for that container. Let me move this little thing out of the way. There we go. We can see down here, there is a root folder in here. And if I pop in here, I'm now in the root file system for the container that's above. So now I can find that library above. So if I go to the lib folder in here, there is a libSSL library. So using shared process namespace, I'm now in the file system of the container that I cared about. So if I pop back, let me find my code. Cool. So what I'll quickly do is I'll quickly show you the code that we're going to run. I apologize, it is a little bit small, but this is the path that we cared about. So you can see that path is the one that's above. That's the path that we're going to connect to. And simply what we're going to do is I've added a little bit of additional code here. So we'll use an environment variable called PID. We'll pass that and the process ID number of the PID that I care about. And then I will call a syscall to routers into that. So as far as the eBPF program is concerned now, it's running inside that other container. And then the rest of it is we're going to use our eBPF program. We're going to link to that userland library that we care about. And then we have a bunch of probes that are going to connect to SSL write, SSL read, and there's a UREP probe return, which will allow us effectively to see all of the reading and writing which takes place. So let's go through this. So let me clear this. Cool. So PID equals 7. Cool. So we can see here it's chrooted inside the file system, and it's now hooked into the SSL library that we can see above. What I will do now is I'll quickly curl. So I'm going to curl Google HTTPS. What I've also done is I've defaulted to HTTP 1.1. There's a reason for that. It makes a nicer demo. I'll show you why in a second. It's not that exciting, but if I now curl, there we go. We can see not only have I pulled out all of the raw and encrypted information from the libSSL library, I can also see all of the headers that were taking place as well. So I've hooked into the library of the container that I care about, and then hooked into the libraries, hooked into it using uprobes. And as curl is doing stuff, I'm pulling data from its library that's actually unencrypted from both reading and writing. So there's the get above. So that's the libSSL write. So we're writing that out. And then here's all the response that we receive. So all of the headers that curl didn't show us, and then the actual HTTP data as well. So as you can see, that's how we can jump between. That's how we can use our eBPF programs in Kubernetes to basically break the container line to actually see what's going on there. Cool. So that is the demo. And most of this I've actually covered before anyway. So that's actually, I think, pretty much everything that I wanted to kind of cover from a Kubernetes and eBPF perspective. Does anybody have any questions around anything that I've shown in terms of, understanding the architecture of Kubernetes in terms of knowing where to attach things to, knowing where to attach networking to, or anything like that? If not, I'll give it a second or two. Cool. Okay. Well, thank you very much, everybody, for joining today. It's been a lot of fun actually putting this talk together to try and work out, kind of how to attach things to the right places. As I say, attaching your probes inside a pod means that you'll see things before they actually attach to networks outside of pods. CNIs doing things in the way to a certain degree and understanding the results of the things that they're actually doing, and then trying to find ways to attach, your uprobes to libraries that are typically hidden away from you. So I think with that, if there are no further questions, thank you very much for joining this week's Echo. For those of you that are going to KubeCon, there is a number of booths around both eBPF and Cilium. So if you are wanting to find people like the eBPF maintainers or some of the core, at least eBPF contributors, if you find the project pavilion, you'll find the Cilium and eBPF booth there. That typically will be staffed by some of the contributors and maintainers of both Cilium and the eBPF project. So please go find those if you people if you have questions. Alternatively, you can head to the Cilium and eBPF day. Outside of there, there'll be a number of people as well that you can ask questions to. So echo this sentiment. Thank you very much. Enjoy, and I will see you all on the next Echo. So with that, thank you very much.